In the following lesson, we lay down the 4-step procedure for conducting a hypothesis test for a population mean. We also discuss the notion of two-tail and single-tail hypothesis tests. The 4 steps are introduced and explained using an example. Let us now lay out the steps for conducting a hypothesis test. We will continue with the beverage bottle example from the last lesson. Let us say that the sample mean beverage per bottle you get across the set of 10 bottles is 199 milliliter, and the standard deviation or variability of these 10 observations, the sample standard deviation is 0.8 milliliter. Step 1 is to formulate your hypothesis. The claim that you wish to test is called the null hypothesis, denoted by H subscript 0. Whatever is not the null hypothesis then becomes the alternate hypothesis, denoted by H subscript A. In our example, the null hypothesis is mu, which is the population mean, equal to 200 milliliter, and the alternate hypothesis is mu not equal to 200 milliliter. Remember, the null and alternate hypotheses are always with respect to some population parameter, in this case the population mean, because a claim is being made about the unknown population mean and you wish to either substantiate that claim or not, based on the sample information you have. Another thing about this null and alternate hypothesis is that it is a two-tailed test. There is a strict equality in the null hypothesis. The claim being made is that the population mean is equal to 200 milliliter. So, you would reject the claim if you get a sample mean way above 200 milliliter, and you would also reject the claim if the sample mean is way below 200 milliliter. We will shortly in these steps lay out what do we imply by way up and way below 200 milliliter. In contrast, you could also have a single tail hypothesis test, which we will cover in a subsequent lesson. Step 2 is to translate the hypothesis test onto a t distribution by calculating the t statistic, which is x bar minus mu divided by s by square root of n. This turns out to be a negative 3.9528. Trying to figure out whether the sample mean of 199 milliliter is way above 200 milliliter or way below 200 milliliter is now equivalent to figuring out whether this t statistic, a negative 3.9528, is way above 0 or way below 0. That is what is meant by translating the hypothesis test onto a t distribution. Step 3 is to determine the cutoff values for the t statistic, so that you can identify the rejection regions for the hypothesis test. This is done by first specifying a familiar value alpha, which in the context of hypothesis tests is also called the significance level. The values of alpha that are commonly used in the industry are 0.05 and 0.01, corresponding to a 95% confidence and 99% confidence respectively. Alpha is the probability that you are willing to accept for making an error, in the sense of rejecting the null hypothesis when indeed it is true. It is also referred to as the probability of type 1 error. In this course, unless otherwise specified, we will use an alpha value of 0.05. So, our cutoff values for the t statistic denoted by t cutoff are those values in the t distribution with n minus 1 degrees of freedom that cut off alpha by 2 probability to the right and alpha by 2 probability to the left. Remember, this is a two-tailed test with one rejection region on the right and one rejection region on the left. Hence, the total rejection probability of alpha gets equally divided across the two rejection regions. Using our familiarity with the T dot INV function for the T distribution introduced in this course, these cutoff values can be calculated as plus minus the absolute value of T dot INV alpha by 2 n minus 1. Note that the plus sign is for the rejection region on the right side and the minus sign is for rejection region on the left side. These turn out to be plus minus T dot INV 0.05 by 2 10 minus 1, which is a positive 2.2622 and a negative 2.2622. In other words, our rejection regions are marked as greater than positive 2.2622 and less than negative 2.2622. Step 4 is to see whether or not the T statistic we calculated in step 2, which was a negative 3.9528, lies in any rejection region. It indeed does lie in the rejection region on the left hand side. Thus, because the T statistic falls in a rejection region, we reject the null hypothesis at an alpha equal to 5% significance level and conclude that based on our evidence, the bottling unit does not put in on average 200 milliliter of beverage in the bottles. As a side note, had our T statistic not fallen inside any rejection region, then we would have not rejected the null hypothesis and concluded that the bottling unit could indeed on average be putting 200 milliliter of beverage inside bottles.